In this video, we are looking at probability. So the first question states that if the probability that an event occurs is 0.5, they want to know the probability that the event does not occur. And so what we know is the probability that an event will occur plus the probability that it does not occur adds up to 1. So if you take 1 and you subtract the probability that something does occur, that leaves you with the probability that it does not. So there would be a 0.5 chance that it does not occur. On our second problem, we have of the last 60 people who went to the cash register in a department store, so we've got 60 people, they are telling us that 10 had blonde hair, 19 had black, 29 had brown, and 2 had red. So they want us to determine the empirical probability that the next person that will come to the cash register has brown hair. So it's based on what's already happened. So if 29 had brown hair, then what we say is 29 out of 60 would be the probability that the next person has brown hair. Okay, when you're looking at this spinner on the next problem, even though there are only 3 colors, you have to look at equal-sized regions. And so basically there are 4 different equal-sized regions. So on the first part, when they ask me what is the probability that I'm going to spin the color red, there's only one section of that spinner out of the 4 equal parts that are red. When we are asked the probability of getting a green, once again, there is only one section out of the 4 equal-sized parts. When we're asked about the probability of a yellow, even though yellow is only one color, it has 2 of the sections out of the 4 equal-sized parts. If you can reduce, always reduce a fraction, so that becomes a half. And then finally, when they ask me for the probability that it is not yellow, you can either subtract the probability that it is yellow from 1, or you could say this would mean the probability that it's green or red. So once again, 2 out of the 4 sections, which would reduce to a half. All right, we have a table in the next problem where we're looking at different types of vehicles with 2 different companies. And it says one person is going to select a vehicle at random from the dealership. So notice there are 207 total vehicles that we're talking about. And it says each choice is equally likely, so they want to know the probability that the person will select a truck. So if we look at the total trucks, there are 86 total trucks out of the 207. And again, if you could reduce the fraction, certainly do so. In this case, it does not reduce. Okay. In the next question, it says if the probability that an event will occur is 2/7, then the probability that it will not occur is 5/7. So what they're asking us is the odds that are in favor of the event. Okay? So if the probability that it will occur is 2/7, that means there are 2 ways that it will occur compared to 5 ways that it will not. So when we're looking at odds, you're looking at number of ways it does occur compared to number of ways it does not. So your odds would be 2 to 5. All right, with the next question, if the probability that an event occur, oh, that's actually the same one, sorry, so let's move right along. On the next one, we're looking at the expected value when you purchase a lottery ticket. So that expected value, notice, is negative $2. So that's what you're expected to win each time, which means you're expected to be losing $2. And the cost of a ticket is $8. So they're asking me to determine the fair price. So fair price is where you actually take your expected value, which is the negative $2, and you add the cost to play, which is $8. And so overall, the fair price for this particular game would be a total of $6. All right, in the next one, we have 2 coins are tossed. Assume that each event is equally likely to occur. Part A says use the counting principle to determine the sample points in the sample space. So the counting principle says that you look at the number of outcomes for each stage of an experiment. So even though I could toss 2 coins at the same time, I'm going to look at it as if I toss the first coin, how many outcomes are there, and then toss the second coin. So there are 2 outcomes on the first coin, times there are 2 outcomes on the second, for a total of 4 outcomes in my sample space. All right, part B, it says construct a tree diagram so you can list the sample space. So again, we're going to start with the first coin, and when I toss the first coin, it can either land head side up or tail side up. And then the second coin can also land head side up or tail side up. And so we branch off of those branches from the first coin. So now, listing my sample space, if I follow my tree from top to bottom, this gives the different outcomes. So HH would be an outcome, HT would be an outcome, and then I come down this side, TH would be an outcome, and then finally T with T. So that would be my listing of my sample space. Okay, so then starting with part C, C says what is the probability that we get no tails? So if I'm looking at my outcomes in my sample space, there's only 1 outcome out of 4 that has no tails. The next question says, what is the probability that we get exactly 1 tail? So exactly 1 tail. When I'm looking at my particular sample space, I notice there are 2 outcomes out of the 4 that have exactly 1 tail. All right, part E wants to know what is the probability that I get 2 tails. So again, looking in my sample space, there is 1 outcome out of the 4 with 2 tails. And then finally, the last one wants to know the probability that I get at least 1 tail. So at least 1 means 1 or more. So when I'm looking at my particular sample space, I see that I've got 1 tail here, 1 tail, and 2 tails. So at least 1 tail, there are 3 out of the 4 outcomes. And then finally, on this last problem, we are considering the circles shown on the right. Assume that 1 circle is selected at random and each circle is equally likely. We're being asked to determine the probability of selecting an even number given that the circle is not green. Now, anytime they use that phrase, that's called a condition. So if it says given that it's not green, we have to throw that out. We can't even consider that that circle is there. So notice the first thing that does is it reduces the number of outcomes in your sample space. I only have 5 outcomes that I'm looking at. Now, out of those 5, I want to know how many of them are even numbers. So 4 is an even number, 6 is an even number. So I would say 2 out of 5 would be my chances of selecting an even number given that the circle is not green.